Hello everyone. Let us continue our discussion on Fourier series by discussing the convergence of Fourier series. We already know that the error signal between an actual signal xt, which is periodic, and its Fourier series representation, summation ck e to the power j k omega naught t, k varying from minus infinity to infinity, we say that these coefficients are chosen to minimize the energy of this error signal. We say that as these number of terms, the number of terms in the summation tends to infinity, we say that this energy tends to 0. Minimizing the energy or saying that the energy tends to 0 does not directly imply that xt is actually equal to its Fourier series representation at all t. Okay, it simply means that if you find the difference between the two, the energy of that different signal would come out to be 0. Is it actually possible that there may be some ck which would become undefined or would become infinity? How to ensure that given a signal xt which is periodic, its Fourier series representation is actually possible? So the conditions that would guarantee that a Fourier series would converge, that means all Fourier series coefficients would be some finite value, was given by Dirichlet. In 1829, the German mathematician Dirichlet gave some conditions that would guarantee, that means if a signal satisfies these conditions, this would guarantee that its Fourier series representation is possible. These conditions are sufficient but not necessary. Meaning if these conditions are satisfied, convergence is guaranteed, but if they are not satisfied, the convergence may or may not exist. The first condition says that over one period of xt must be absolutely summable. That means over a period, if mod of xt dt is finite, this would ensure that mod ck is also finite. We know that ck is 1 upon t naught integration over t naught xt to the power minus j k omega naught t. So mod of ck would be less than or equal to mod of this term the modulus of e to the power j omega naught t or minus j omega naught t is 1. That means mod of ck would be less than equal to 1 upon t naught integration over t naught mod xt dt. That means if this term is less than infinity, then mod of ck is also less than infinity. That means there would be no such Fourier coefficient that would become infinite. A signal that the second condition of Dirichlet is that over a finite interval there must be finite number of maxima and minima. Meaning if there is a signal which within a period has infinite number of maxima and minima, Dirichlet's condition says that its Fourier series convergence cannot be guaranteed. The third Dirichlet's condition is that over a finite interval or over one period, there must be finite number of discontinuities in xt. That means over a period, if there are discontinuities in the signal, the number of such discontinuities should be finite, and each of these discontinuities must be finite. That means that the type of discontinuity should be finite, like a jump discontinuity, and not a discontinuity where signal becomes infinite. that is not a finite discontinuity. So Dirichlet's third condition says that if in a finite interval of time there may be discontinuities, but if the number of such discontinuities is finite, then Fourier series representation is still possible and its convergence is guaranteed as long as each of these discontinuities is finite and the number of such discontinuities is also finite. Dirichlet's third condition is of particular interest here because if you remember, mathematician Lagrange vehemently opposed the use of trigonometric series to represent signals with sharp discontinuities. For example, a square wave. Okay. Dirichlet's third condition says that if the number of discontinuities is finite, for example, in a square wave over one period, the type of discontinuity is finite, so it's a finite discontinuity, and the number of such discontinuities over one period is also finite, then Fourier series representation is possible. In fact, Dirichlet's condition guarantees that xt is in fact equal to its Fourier series representation at all times t except at the points of discontinuity, and at the point of discontinuity the Fourier series converges to the average value of the discontinuity. That means the average value on either side of this discontinuity. For example, the square wave clearly satisfies all the Dirichlet's conditions. That means if we try to write its Fourier series representation, it is guaranteed to converge. And what would happen is that its representation at all time t except for the instances where there is a discontinuity, everywhere else the Fourier series representation will actually converge to actual square wave value, but at the point of discontinuity the Fourier series will converge to the average of this discontinuity, meaning average of whatever was the value at, say if this is t1, average of whatever was t1 minus and t1 plus, whatever is the average of these two values, that is where the Fourier series will converge, but it will converge. That is what Dirichlet's condition guarantees. To understand this better, let us continue our discussion on Fourier series representation of a square wave in the next video.